Welcome back. We're going to be studying part 2 of 2 of the function, where we're going to be using a tool that we've just learned about, the spreadsheet, in order to be able to interpret and evaluate functions. Looking at exercise 2, we have the squaring function, which is defined as follows. X goes to x squared, where x is a set of all real numbers. So what is the value of the function at 0, the function at 3, the function at -2, and so on and so forth? And then what is the range of f, or the output? Now, while we could type each of these individually to a calculator, there's actually a very handy tool that will do this for us, known as, of course, a spreadsheet. In a spreadsheet, we can define a function to take the values from one column, so let's put this to that input column, and give us an output column. Since our function says take whatever is here in the input, in this first case 0, take that, and I'm going to say A4 gives us the value right there, and use the caret button above the 6 to square it. That gives us our output. Now, instead of having to type these individually, I can go and just type each of these values by themselves. So let's say -2, I think is, or I'm sorry, 3 is the next one, then -2. So 3, then -2, then, how do I do square roots? That's a great question. If I want to find a function in Google Sheets, I hit equals. That tells them I want to do a calculation, and I start to type square root. You'll notice this SQRT, which stands for square root of 3. And it gives me the estimation of that, -2.5. For fractions, you might want to type them as a calculation rather than trying to convert them. And then what about these two variables? We'll get to in a second, because spreadsheets are amazing, but they work best with numbers. And voila, here's our outputs. Let's say I want these all in fractions. So I can format the numbers into, let's see, all sorts of different types. Can we format them to fractions here? Let's see if we can do that here. Let's type fraction. Notice there's no. I can then take this input-output table and substitute it over to here. If I want, you can even link it so that it'll update as I put it in. Now, why is it only pasting one point? And here's my input-output table. Notice it's linked, and I can always update or change the range. Now, what about f of a and f of 3 plus a? So if the input is a, then my output will be a squared. On the other hand, if my input is 3 plus a, then my output will be 3 plus a squared, which means I just have to multiply 3 plus a times 3 plus a, which if we do a little bit of foiling, that's first plus outer plus inner plus last, with a little bit of cleaning up, instead of stand before, that's a squared plus 6a plus 9. The output of f is exactly what we're looking at. If I think about the output of f, whatever I put in to be squared will always have a positive answer. So the output of f is all positive numbers and 0. When I want to think about the subset of the real numbers that could be used as a domain, or the input of the squaring function, to create the range with the same output values as a sequence of square numbers, 1, 4, 9, 6, 25, well, that's pretty intuitive. In order to get 1 as a square root, that's 1 squared. The square root of 4 is 2. The square root of 9 is 3. The square root of 4 is 16. The square root of 25 is 5, and so on and so forth. We'll continue exploring this with things that are a little more complicated in exercise 3.